Welcome back, guys. Today my topic is graphical representation of thermodynamic process, means graphs and related problems. Same way, we are called indicator diagrams also. What we will call them indicator diagrams. Indicators. So now come to the isothermal process first of all. So if you see isothermal process here, in isothermal means temperature is constant. Temperature constant means according to ideal gas equation, PV is equal to constant. PV is equal to constant, nRT. So here T constant, N constant, R constant, therefore PV is also constant. That means P inversely proportional to 1 by V. So dP by P minus dV by V is called slope of this PV graph. And here P inversely proportional to V. So explaining about Boyle's law. When P tends to infinity, V tends to 0. V tends to infinity, P tends to 0. Means V reaching infinity, V value reaching infinity. Here you can see clearly. The V value reaching infinity. So P value reaching 0. Here, right? So V value reaching infinity, P value 0. P value reaching infinity, V value becomes 0. So this is isothermal graph. This graph is equal to PV is equal to constant. So in polytropic process, PV power n is equal to constant value. So now P and T graph will see pressure and pressure versus temperature graph. So as we discussed, isothermal process temperature is constant. So this is the graph B to A or A to B. A to B means pressure increases, B to A pressure decreases. At constant temperature, the pressure is increasing or decreasing. That depends on the arrow mark B to A means pressure decreasing at constant temperature. Means P at B is more and P at A is less, we know. So P inversely proportional to B, therefore VB less than VA. VB less than VA means it is compressed. So this isothermal compression represent this process is isothermal compression. So work done, that is nRT into log of VA by VB, right? So minus of nRT into log of VB by VA. That is compression represents isothermal compression. So coming into V versus time graph for V versus temperature graph for isothermal process. So you see here VA and VB on y-axis. VB is greater than VA. It is very clear from the graph. And T is temperature, any one temperature. This is T is constant. TA is equal to TB. TA is equal to TB. So here also this is TA is equal to TB temperature. V and V, P inversely proportional. Therefore, V greater than VA, VB greater than VA, PB less than PA. That is all. So whereas coming into in PV graph, so this is the graph giving of one gas of expansion, and this is giving the graph one gas of expansion. So now pressure decreases, the volume increasing. So that is work done on the surroundings by the system. Volume increasing means work done by the system. So positive work done. So this gas temperature is T1. At constant temperature, pressure is decreasing and volume is increasing. At constant temperature, pressure decreasing, volume increasing. So that is T1 and T2. T1 is temperature is constant along this line. And along this line, second line, this is the second line, this is the first line. Along the second line, temperature is constant, that is T2. Along the first line, temperature is constant, T1. So these two temperature graphs are isothermal graphs, PV graphs in isothermal process. Give the slope of this graph will be give the temperature. If they are parallel, those graphs, those lines are parallel, the graphs at different temperatures are parallel each other. They are called isotherms. These graphs are isotherms, means same temperature. So these are the 4 types of graphs for isothermal process. So now we'll change these graphs into in different cyclic process. That models I will explain later. All combined process. First we'll individual process, how that all 3 quantities relation, how we'll draw, that we'll discuss. Then after we'll combinedly we'll discuss, right? Now isobaric process. Isobaric, that means pressure is constant. So according to ideal gas equation, pressure constant means V proportional to T. So that nR by P into T. V by T is equal to nR by P, means slope of VT graph is equal to pressure. Remember this. Slope of VT graph is equal to 1 by P, means some constant by P. Slope of TV graph is equal to directly proportional to P. The slope directly proportional to P, the slope of VT graph directly proportional to VT graph, indirectly proportional to 1 by P. The slope of TV graph, means T on Y axis, T by V, is directly proportional to pressure. So these 2 points I will give the explanations here. So VT graph. So this is one graph, means one pressure it is giving. This is the another pressure is giving. So graph 1 is P1, consider pressure 1. The graph 2 is at pressure 2. Because V proportional to T, that means you will get here V is equal to mx into T, right? So this is V proportional T into V proportional to T, means V equal to m into T, mx. So V is equal to some m into x, I can write. Means it is a straight line equation, m into T. Straight line equation with the slope nR by P. So your slope is tan theta 1, theta 1, theta 2 if you take. From the graph, theta 2 is more than theta 1. That means theta 2 is more, means the theta 2 represents the pressure P2 for V and T values. You understand, right? V and T values, the pressure represents, P is represents the slope of VT graph. That is P2. P2 less than P1. So more slope, less pressure. Smaller the pressure, more the angle. Smaller the angle, more the pressure. Or more the slope. Pressure is nothing but slope here. So I hope slope and VT graph, slope and quantity, whatever that, inversely proportional. Here VT graph we are discussing. So the slope of VT graph is pressure, that is inversely proportional to slope. Okay, slope is more means pressure is less. Slope is less means pressure is more. So this is clear. Now for isobaric only, PT graph. Isobaric means pressure is constant. So A to B is some temperature is raised at constant pressure. Temperature is raised. TA is less than TB, therefore temperature is raised. Then volume also increasing. At constant pressure, temperature rises means volume increases. So this is Charles' law, V proportional to T. At constant pressure, V proportional to T, Charles' law. Temperature rising, volume is increases. VA to VB. So this is expansion, right? Volume increasing means expansion. Isobarical expansion. So now here also, P and V graph. P is equal to here constant. VA, VB from the graph. VA is less than VB, means expanding here also. Then TA is less than TB. Time means temperature is increases. It must and should, right? Okay, now at constant pressure, volume is increasing means the next quantity temperature increasing. At constant pressure, temperature increasing means next quantity volume. The volume cannot be constant, right? There is no chance. Then graph will not exist, right? Here only the graph is not exist for that one. So that is. So volume and temperature both are increases. The slope increases. That is pressure. Inversely, the slope is increases. So that is about isobaric process. And these are called pressure lines. So now, and if you see here, the pressure A and pressure B in this graph, VT graph for isobaric process, pressure A is equal to pressure B. So pressure A equal to pressure B. On P1 also and P2 also, pressure A and pressure B is equal to P2. On the second line, pressure A is equal to pressure B on first line. These two pressures are different. But at point A and at point B, pressures are same. So that I hope you understand. Right. Now coming into isochoric process, means volume constant. So volume constant means P proportional to T. That equal to P equal to M into T. M is equal to slope here. NR by V is the slope. The slope of PT graph, tan theta, is equal to NR by V. Means in the PT graph, more slope, less value, less slope, more value. Same like isobaric process, the slope of VT is pressure. Here the slope of PT graph is P versus time temperature graph is value. So are you following this? I think so. Now see PT graph I'm explaining. So this is the slope of PT, P by T is equal to this is NR by V. So which is constant slope. The slope is M value, P by T. So T by V you can take. For T by V reverse, the slope is proportional to V. So before I said. And here on the line, first line, so this is V1, V1 greater than V2 because tan theta 2, according to here given diagram, theta 2 is greater than theta 1. Therefore, tan theta 2 is equal to P by T, that is 1 by V2, NR by V2, NR by V1. So NR by V2 is greater than NR by V1, therefore V1 greater than V2. Slope is more, slope angle is more, it represents value is theta 2 and V2 is less. Theta 2 more means V2 is less. Now coming into here, first graph, PV graph for isochoric process. V is constant. So this is V is constant. VA is equal to VB. But from the graph, PB greater than PA. Graph means pressure increases. At constant volume, pressure increasing means must and should temperature also increase. Then only pressure can increase at constant value. In the cycle 2, if you are increasing pressure, the gas temperature increases, so it will be try to burst out, right? Not by increasing the value. Volume in the tire is same only. Tire volume of the tire is same. Now coming into this one, VT graph for isochoric. V is constant. So V value at A and V value at B is same. So volume is constant. But if you see time on temperature on x-axis, TA less than TB or TB greater than TA. Then according to isochoric process, P proportional to T. Therefore, T less means PA also. P is less than PA is less than PB. That means the pressure increasing by increasing the temperature where volume is constant. So this is Gay-Lussac law. Am I correct? Right. P proportional to T, Gay-Lussac law. Isochoric process giving the idea of Gay-Lussac law. Isobaric process, Charles law, where V is proportional to T constant at constant pressure. That means temperature increases, volume increases. Temperature decreases, volume decreases at constant pressure. Isothermal process means constant temperature. At constant temperature, pressure and volume are inversely proportional. Temperature is not changing. Pressure increases, volume increases. So pressure increases, volume decreases inversely. Right. So now here adiabatic process we are not discussing. There all PVT all changes. Right? There is no one constant term in adiabatic. Among PVT, Q only constant. Energy is constant there. That is why there is no graph like this PV, PT, VT indicator graph. Right. Some example to understand this graph and converting the given graph into required quantities. For example, here TP is given. I am going to convert into that is TV or PT, PV like that. So, but this is the question asking about energy. Okay. So, before going to this question you can try after discussing this question. See. So, this is a basic question here I am going to explain. So, this is the main question for all clarities. So, basic. First of all, understand the question here. ABCD is the one cyclic process. Pressure and volume. Therefore, isobaric, isochoric process are there. Isobaric, isochoric in the cyclic process. And T1, T2, T3 are isotherms because they are parallel isotherms. So this process is isochoric, isobaric. D to A, volume is constant VA, therefore isochoric. A to B, pressure is constant, that is PA or PB, pressure is constant, isobaric. Same B to C, D to C. So here, how to calculate the work done? Already in previous class, we know isobaric process, what is the work done? What is the internal energy? First law of thermodynamics, how to apply? One table I have given in previous class. So that the work done calculation. If they are asking what heat energy asking or internal energy asking or work done is asking. Based on that, we have to apply First find out the which process and required formula apply. Okay, now. So now I'll try to explain. See, along the AB path. So if you take AB path, is isobaric path. Very clear that is. And VA less than VB from the diagram. So TA less than DB. Now in isobaric process, work done equal to PdV. Therefore, PA into here, VA minus VB. So that is work done actually. But VA, VB values are not given. So instead of VA, VB, they have given temperatures. So change this work done P into VA minus VB. A isobaric process. So now VA is equal to what I can write? NR into TA by P according to isobaric process. So that is PA and PA minus NR into TB by PA only I will write because PA equal to PB. So PA get cancelled. Therefore NR TA minus TB. NR into TA minus T2A, right? So VA minus VB. So your work done. Then VB minus final value minus initial value 100. VA, this is VB minus VA. So now TB minus TA. So now TB, they have given 400 Kelvin. TB means T1 here I have taken. And TAC, T2 temperature that equal 2000 Kelvin. And T3 is 1000 Kelvin. So now substitute, you will get 2000 R is the work done. And along the AB path, internal energy also find out. Internal energy du is always NCV delta T. In that no doubt at all. Internal energy is equal to NCV delta T. So this is equal to F by 2 into NR delta T also. Because CV is equal to FR by 2 I can write, right? In kinetic theory of gas. CV, CP, CV values. There again I will explain work done, how CP minus CV is equal to R from the work done process. There we'll discuss about that, right? So CV is equal to, again I am giving FR by 2. CP is equal to F by 2 plus 1 into R. Here F is number of freedoms. Okay, no? F value CV for monoatomic is 3, diatomic it is 5, triatomic it is 3. And CP plus 2 you have to add that. Because CP is equal to CV plus 2 calories. R value is 2 calories. That's why CV plus 2. Okay, no? That means monoatomic 5, diatomic 7, triatomic is 4. So here why triatomic is 4? Again I will explain in kinetic theory of gas. Wait for that video, right? I hope you understand. Along the AB path, how to calculate the energies? Work done, internal energy. Internal energy is equal to, I said, NCV delta T. CV is equal to here. We are given monoatomic gas in the question, C1s. That's why it is 3R by 2 into temperature. This one, 2000 kelvins. So now this will be 3000 R. The total dq is equal to 5000 R. Similarly, BC, same, work done equal to PdV. So BC indicates, B2C indicates isochoric process. Therefore, work done is 0 in isochoric process. Then du is equal to NCV delta T. Again, so here TC TB, TC TB means here TC is equal to T2, TB means T1. So minus is coming, minus 3000 R, 3000 R. So here TC, once again check here, TC is equal to T2, that equal to 2000 Kelvin, TB is equal to 4000 Kelvin. Therefore, your minus work done will come. Right? Pressure is decreasing at constant value. Then work done is, means internal energy is negative. Work done is 0 there. At constant value, PdV work done is equal to 0. Internal energy is negative. So now dq is equal to u plus dw first law. Similarly, dA and path CD path and dA path find out all same process. Equation, dw equation, du equation and adding them. So now this table, I'm decreasing the size once. A to B, isobaric process, du value, dw value and dq value. We see here, it's a cyclic process, right? In the cyclic process, the total internal energy is 0. The sigma of du is equal to 0. Therefore, sigma of dq is equal to sigma of dw. This concept here you only will get see. Sigma of dw is equal to 1000. Sigma of dq is also 1000. After adding all. So final conclusion is what? In cyclic process, the total internal energy is equal to 0. Because here one more question you will ask. For example, A to C. The A to C is equal to 2000 is sigma q, right? Means plus 2000. And CDA, C to A minus 1000, right? That means here released. C to DA is released. A to ABC is absorbed, means transfer. Means ABC internal energy is not zero. If you see A, B to C internal energy is here 0. And CDA is also internal energy 0. Okay. And ABC here internal energies are means Q values are equal. Not equal, right? This is C 2000 means heat absorbed plus 2000 will come. A to B to C, heat is equal to 2000 R. That means plus absorbed. That means given. We are given to the system. System is absorbed. From the system we are observing means it is negative. The system is given means we are giving and it is taking. Right? Now C to D to A. So this is how much heat energy? Minus 1000 released. Okay, heat energy is released. The same way in Kirchhoff laws will apply. When you are going to positive terminal to negative terminal, jumping from positive terminal to negative terminal, their potential is releasing, right? So there will take negative. When you are jumping from negative terminal to positive terminal, you require some energy. So you are gathering from surroundings. That is positive. Same like this, remember this. Kirchhoff laws, potential how to take positive and negative, plus C minus C. When positive to negative you are jumping means potential is negative, releasing negative. You are negative to positive are jumping means the cycle indicates negative terminal to positive terminal, arrow mark or current direction. Then you will take it is positive, taking surrounding and jumping, right? So okay, this is related to this graph and the given concept, right? So I hope you understand this, how to calculate along each process. Conclusions I have given in cyclic process, d is equal to 0, sigma du is equal to 0, and sigma dq is equal to sigma dw, sigma adding. So clockwise, cyclic process clockwise means positive and anti-clockwise means negative. And one more conclusion you can write here. I have given AB means total internal energy is 0, but A to B internal energy is not 0, B to C internal energy is not 0, and D to C and D to A internal energy is not 0. That means internal energy or whatever Q or W depends on the condition or process only 0 or something value. Okay, I hope you understand this question. So coming into same way here, this question. So there are 2 moles of ideal monoatomic gas is given, undergoes a cyclic process. Therefore, in that no doubt at all, du is equal to 0. The temperature in different states are given by. So this is 1 consider, this is 2 consider, 3.4 point. That means 6 Ta, 3 Tb, 2 Td, Tc is equal to 800 kelvins is given. That means Ta is equal to 300 kelvins, Tb is equal to 600 kelvins, Tc is equal to 1800 kelvins, and Td is equal to 900 kelvins. Temperatures of those points. Other than nothing values are given. P values are not given. So he's asking work done alone. So work done equal to dq. Total work done equal to dq. Heat energy also. So total heat energy and it is cyclic process positive. So it required. Okay now. It is taking the energy to be like these states. Right. So this is pressure and time means time temperature and pressure graph. So this A and B are at constant pressure. They are isobaric process. Constant pressure means isobaric. In isobaric already discussed, the work done equal to NR into delta T. A to B, B minus A. 600 minus 300. Right? Similarly now, B to C work done. And if you see here, T P graph, T by P is equal to V by NR according to ideal gas equation. This is ideal gas only now. Therefore, T by P is equal to V by NR. The slope of T by V, T by P is equal to V. So this B to C, V is constant here. The slope of this one is constant. And it is more also. So VB and VC are more than VA and VD. This point remember. So here Because see, this is the TP graph. The slope of BC line, the slope of BC line is greater than slope of AD line. Therefore, the slope of TP is giving direct volume proportional to volume. Therefore, VBC, VB, both are same. That value VB or VC value is greater than VA or VD. I hope you understand this, right? Right. So now work done is equal to 0 along the BC because it is isochoric process. In the isochoric process, work done is 0. Same AD also 0. You have to find out then C2D, temperature decreasing at a higher pressure. So therefore, work done to C2D is equal to NR into D minus C. TD minus C. 900 minus 1800. Therefore, minus 900. NR into 900. Now, total work done sigma EW is equal to adding this work done and the clockwise. So therefore, you will get here, this is NR 300 minus NR into 900. Therefore, 2 into 600 into R. This is minus 600 R will come here. That is equal to minus 600 R will come. NR will come. So N is equal to 2 moles is given, N value. And this is positive only. Cyclic process is the positive energy. Positive of minus 600 NR. Positive 2 into. So positive 2 into minus 600 into R. That is equal to minus 1200 R. This minus is not indicating the clockwise is negative. Clockwise is positive, anti-clockwise cyclic process is negative. Already we discussed in the previous class, first part of this thermodynamics, right? So these two problems over. I hope you understand this. So now another example of cyclic process. How to calculate the work done here. So here see, so observing the 40 joules during the path AB, here the dq is equal to 40 joules. And here dq is equal to 0. And here released 60 joules. Therefore, sigma dq is equal to 40 minus 60 or minus 60 plus 40 minus 20 joules. Total, overall, it is releasing the energy, heat energy. Okay. Now, this released heat energy means here negative work done. Releasing means what? Negative work done on the surrounding. It is giving to surrounding means negative work done. Right. So now, negative heat energy. Right. So now, work done you have to find out. So, internal energy in the cyclic process is 0. So now, we want to work done. Work done in the gas CA only. So now, at AB is given 50 joules of work done gas during the path BC. Here they have given du is equal to, this is 50 joules. And here 0 because constant value now, it is 0. And here CB du, this is constant pressure here. This is CA is constant pressure. Here du you have to find out. NCV delta T, that equal to is asking to find. Anyhow, it will be 0 on NCV delta T. That is not asking. So now work done here. CA, W I will consider. Therefore, total work done is equal to here. And here it is positive or negative. Work done from C to A. Positive or negative means at constant pressure, the volume is increasing, right? The volume C to A is increasing. Volume increasing means compulsory it is positive work done. And the cyclic process is anti-clockwise. Therefore, work done is equal to negative. Negative of minus 50 plus W is equal to minus 20. So therefore, minus 20 plus 50 is equal to minus W. W is equal to minus 30 joules. Verified. So in that, no doubt, minus 30 joules is the work done. So now coming into same model, this is cyclic process. Du is equal to 0. A, B, C, A. And here du along CA is given minus 180 joules. Not 0. Total is not 0. dq along AB dq is given. And along CA, C to A, du is given. And along BC, again dq only given. Because dq is equal to du here, that equals 60 joules. Because dw is equal to 0. The dq is equal to 60 joules. And now, is asking in the cyclic process, the total work done is how much? So here is the work done is there. dw is not equal to 0 here, and here also dw is not equal to 0. Therefore, total work done is equal to dq minus du. So 310 minus 180, that equal to 130 joules. So I think it is correct only. Du is not equal to 0 here. The du total is equal to 0, but du Along Ca is given, therefore I have to subtract 180 joules. This something take clarity later. Right. One more an example I'll explain. So now this question, see, this is the question related to converting the given graph into required graph. Means VT graph they have given, asking to convert into PV graph. From the given diagram, YZ represents isochoric process because volume is constant Y to Z. And at Y, Ty is more than, so Ty is more than Tz. And volume is constant means Py is more than Tz. PET is proportional. First, in isochoric process, I have given graphs, right? Conditions. Whereas coming into Z to X in the graph, isothermal process that is. That means Tz is equal to Tx. Tz is equal to Tx. So that is equal to Tx here. And here you cannot, means here, at T is equal to constant, V inversely proportional to P. That means here Vz is more than Vx. Therefore, Pz less than Px. Okay. So Pz, this is Pz, is less than Px. That equal to Px overall. Px is less than Pz is less than Py. Py is more. So this is the relation from the given graph. Relation between the three quantities, how they are. Means Y to Z. Temperature, Y to Z temperature decreasing, pressure also decreasing. Volume is constant. Z to X, temperature is constant, volume is decreasing. And X to Y, slope of V by T. Again, X to Y is slope of V by T, you can write. That is 1 by P. Right? Right. So now, here I have given clearly, Vz is greater than Vx, Pz is less than Py, Px equal to Py. Because slope only, no? Constant slope here given. So P at X and P at Y is equal. And P is inversely proportional to V. Based on this data from the graph VT, is asking to PV graph. So you know PV graph means Z and Y are same, and Y to Z value is means Py is more, right? And Py and Px are same, and Y to Z, so Py and Pz. That means Pz is less. So here the Z point is Pz is less. Z point is here, and Px or Py is more. That's so here point. Px Pz points, okay, wow. And now Vx is, so here P inversely proportional to V, therefore Vx is less than Vz. So Vx is means Vz is greater than Vx. P inversely proportional to V. So therefore Vz is more. This is a more and Vx. So now complete the Y to X to Y, Y to, and here X to Y is expansion. Y to Z is compression. That's why Y to Z like this. And here Z to X is isothermal. The PV graph isothermal curve is like this. And if you see here, in isothermal, Z to X, it is compressed. That's why here also Vz to Vx compression. Arrow mark is like this. So arrow marks also important. Why this arrow marks only has to come? So Px and Py equal. Whatever the arrow marks you can put, right? Right. And Py and Pz values. Py and Pz values are Px and Pz values. If you check means Pz is less, Py is more. That's why this graph arrow mark Y to Z. So I hope you got clarity how to change the arrow mark and everything. So this process is given here. VT graph cyclic process is isothermal process, and isochoric process, isobaric process. Three process in anti-clockwise direction. But here also isobaric, X to Y isobaric in PV graph, right? Y to Z isothermal, isochoric, and again Z to X isothermal. But here if you see it is clockwise, here it is anti-clockwise. I hope you understand this. This how to change the one VT graph to PT graph. Now another model A, B, C, D. With the one process is given. It is not a cyclic. Cyclic means the state, initial state and final state should be same. But initial state have pressure more, final state has pressure different. And the temperature is also different. TA, TB are equal. If you see, AB is isothermal. PT graph no isothermal. T is constant. CD also T constant. B to C, P by T slope. P by T slope means 1 by V. The slope of 1 by V is constant. 1 by V is constant. And PB is equal to PC. Oh, sorry, VB is equal to VC. Because the slope of P by T is 1 by V. Therefore, VB is equal to VC or VC is equal to VB. And it is clearly from the graph, PA is greater than PB. And then PA is greater than PB at constant temperature A and B points. So therefore, P inversely proportional to volume. Therefore, VA less than VB. PC greater than PD. Values of PC greater than PD from the graph values. Then automatically VC less than VD because P inversely proportional to 1 by V at a constant temperature. Boyle's law. So now this will be, this given is I am converting into VT graph. You can convert into PV graph also, but you already know the Tundal retry. So now VT graph. So coming into AB is isothermal, and at A VA is less, VB is more. So VA is less, VB is more, and temperature is constant TA TB. So this is graph. A to B temperature is A to B temperature is constant. Then you can ask me here B down B and up A you can take null like that. But conditions here VA less than VB. So VA value is less than VB value. Therefore A and B like this only have to take A to B. Now B to C. VB and VC are same. So this is a V graph. So V BC same line. So this is isochoric line BC line I have taken. And again coming into here VC less than VD VC and more point is D have to take here. So this is VD. VD value. VD value, VC value, VA value, VC or VB value. So I hope you understand this changing. That you can change into PV graph also. Coming into this question, 1, 2, 3, 4 is the cyclic process, clockwise cyclic process is given, and PV graph is given. So if you see 1, 2 is 1, 2, 3, 4 are isochoric process, volume is constant, P proportional to T. The P by T is equal to slope of the PT graph. If you are taking P by T is equal to slope of 1 by V. The slope of PT graph is equal to 1 by V will come. And coming into 2, 3 and 4 to 1 are isobaric process. Isobaric process, that means P is constant, V proportional to T, V by T is equal to pressure constant, right? So now is asking to change into TV graph and PT graph. TV graph. So TV graph I will explain, PT you try, right? You people try to understand. So here VT graph and TV graph, they are asking TV graph, but I have done VT graph also. So for understanding, so from the given data, if you see the graph from the given data, this is P1, this is P2, this is V1, V2, this is V3, V4. So V3, V4s are greater than V1, V2, that is clear. And V1 equal to V2, V3 is equal to V4, and this V1, V2 less than V3, V4. And P2, P1, P2 is more than P1, and 2, 3 are P2 is equal to P3, which is more than P1 is equal to P4. I hope you understand this. So given PV graph, therefore at constant value P proportional to T, therefore P1 less than P2 means T1 less than T2. P4 less than P3 means T4 less than T3. So these points, these relations, compulsory you have to understand. So how I am getting these relations means from the process, which process, 1 to 2 which process, 2 to 3 which process, there which quantity is constant, then that constant means remaining quantities how they are related. This is very important according to ideal gas equation you have to consider. From that only we will get remaining changing into quantities. Now coming into VT graph, they are asked TV graph, now that I will explain because time is running. I want to complete one more problem like this. TV graph. So at 1 and 2 if you see volume is constant and the slope of TV graph gives the pressure, right? Slope of T by V is pressure. So according to ideal gas equation, T is equal to nRT by V. So nR is constant. Therefore P is equal to slope of T by V. And you see here P2 is more than P1, right? So 1 and 2 points I have taken, and the same way 3 points I have taken. And the slope of TV graph is more means pressure is more. P2 is more. P2 is more, that's why 2 points and 1 point I have taken. Why you have to take like this means slopes you have to take. Why this graph is like this, what will come like hexagon. This is not a rectangle or a square or a rhombus. Maybe it will be rhombus or trapezium. It is trapezium. Trapezium also not, no parallel sides. Okay, slopes. Why the slopes are came like that means the slope of TV graph directly proportional to P. Okay, directly proportional to P. Slope more means pressure more. So here the more slope point means more pressure point. P2 is more pressure. P2 and P3 are more than P1 and P4. That's why the slope of 1, 4 is two slopes I will take with different angles, theta 1 and theta 2. So that points I will give 1, 2, 3, 4. Similarly, VT graph means reverse will come. That's enough. So here this is anti-clock, this is clockwise. And slopes. Slope of E by T is inversely proportional to P. Slope more means less pressure. Here T2 is more. T2 is more than T1. Therefore, P2 comma 3 is less than, means T2 is more. Therefore, P2 comma 3 is more than, that means slope T2 measure 1 comma 4. 1 comma 4 less than P2 comma 3. So here see T by P proportional. Therefore, T2 greater than T1. Proportional means the T2 represents pressure 2 comma 3. 2 comma P3. P2 comma P3 is greater than P1 comma 4. So both are same represented. But values on y-axis, x-axis, what values you are taking, that will be different. Similarly, one more graph, VT graph is given here. In this question, PV graph is given, but here VT graph is given. Fast I will do it. See, 1, 2 points is isothermal, 2, 3 is isochoric, volume constant. So 3, 4, 4, 1, similar. So now 1, 2, 3, 4 isothermal, T is constant. T constant means P inversely proportional to V. That means P more means V is less. In the graph, V1 less than V2, therefore P1 greater than P2. In the graph, V3 greater than V4, P3 less than P4, V proportional. And here T1 and T2 is less than T1 and T1 equal to T2 values, and it will be less than that value T1 or T2 value less than T3 and T4. So this is the data we have. Now PV graph and PT graph. In the PV graph, T is constant means P inversely proportional to V. Already PV graph for isothermal process is a curve, it will come right up. P tends to infinity V0, V tends to infinity P0, that curve. Isothermal curves right up. So that will be 1, 2, 2, 4, 4, 2, 3. Like this curves will come. Why like this only have to take 1, 2, 3, 4 has to come means, so this data will help you to understand. So similarly PT. So the PT graph, the slope of PT graph gives the value, right? Slope of PT graph is gives value, and here the value of which one is more here? V2 is more. Here slope of PT graph is equal to 1 by V. Therefore, the slope more means V is less. Here theta 2 is more. Therefore, less value has to come. V2 3. Here V2 is less, right? V2 is more, and V3 is also more. Therefore, 2 3 is PT graph, right? PT graph. P by T is equal to 1 by V, right? The slope more means values are less. So V2 3 is less. V1 4 is more. Okay. So that is. So this is the graph. 1, 2, 3, 4. 1, 2 is isothermal, like that. So am I correct? Right, correct only. V1 less than V2. So V1 4 or less. Okay. So this numbers you have to check. This is 2 3 and it is 1 4. Because slope is less, V1 and V4 are more. Right. This is only come. This is V1 and V4 are more. Right. 1 4 2 3. Numbers we can check. This is V1 to 4. V1 and V4 are equal. V1 and V4 are equal. Right. V1 and V4 are equal. And you should have less value than V2 3. Therefore, here more V2 3 is more. Right. More value. Okay. This is 2 3 1 4. Correct only 1 4. Before first run only correct. I made you confused. Don't confuse. V1 4 are less. V1 is less. So this is 1 4. This is 1 4. V1 4 less. Because theta 2 is more means one value is less. So this is this value. V1 4. This value is less. Theta 2 is more. And theta 1 is more. Theta 1 is less. Slope of PT graph is less. Theta 1 is less. Then its value is more. The more value is here 2 and 3. 2 comma 3. So V2 this is wrong. V2 3 greater than V1 4. Right. 2 3 represents theta 1. 1 4 points represents theta 2. Theta 2 is more means 1 4 is less. That equal to V1 4 less than V2 3. No need to confuse. So I have given clarity. Right. Thank you. Thank you all, everybody. And here I want, so this way means already writing the matter and explaining is correct. Or taking the question and explaining by writing means step by step writing is comfortable, you people, that you can comment. Again, I'm requesting you people who are watching my videos. I am means like this full data is writing and explaining it is comfortable, or only question is writing and explaining with the matter right by writing is comfortable. I hope you understand. Comment in my comment section. Thank you all.